Okay, so number 2, letter A, sketch the graph of f of x equals 2x squared plus 8x plus 7. And I'm going to write that under here, just y equals 2x squared plus 8x plus 7. Identify the vertex, the axis of symmetry, and the x-intercepts. And we can also check our answers using Desmos by just typing this function in and checking all of those pieces. So I'll show you how to do that as well. And we are going to round to the nearest hundredth. So to get our vertex, we're going to go ahead and convert this into standard form. So what we'll do, just like before in the last example, let's go ahead and move the constant to the other side. So we'd have y minus 7 plus a blank to complete the square equals, let's factor out this 2. That'll leave us with x squared plus 4x, and we're going to put a blank to complete the square. Okay, this would be another good one now that we've done a few to pause the video and try this on your own from here. But if you're not quite comfortable with that yet, the next step would be to just rewrite what we have on the left side equals 2, and then write this as a perfect square on the right side. So we'd have x, and then half of 4 is a positive 2. Positive 2 squared is 4. But I factored out a 2, so we're actually adding 8 on this side. And then our last step is to move the 7 and the 8. So we'll add the 7, subtract the 8, add the 7, subtract the 8. That leaves us y equals 2, and then x plus 2 squared, and then 7 minus 8 is a negative 1. So there's our standard form. Now we need to find the vertex, the axis of symmetry, and the x-intercepts. So our vertex here in standard form is our h value and our k value. So the h value is pulling out of parentheses. Whenever you take anything out of the parentheses, we're going to change the sign. So if that's an x plus 2, the h value is a negative 2. The k value is not in parentheses, so that stays a negative 1. So our vertex is negative 2, negative 1. I can put that on my graph, and I'm just going to label it with a V so I know that that's the vertex. And then just by observation, if we look at this leading coefficient, this a value is positive, so our parabola should open up. So it's going to look something like this, but we want to get more exact. So we're going to find the axis of symmetry and the x-intercepts. So let's go ahead. Your axis of symmetry comes directly from this value. Remember, it runs straight up and down through the vertex. So the axis in this case hits the x-axis at negative 2. So this is your axis of symmetry. Here's your vertex. Notice how those x values are exactly the same, and they should be. So those two come directly from each other. They are correlated. They have the same x value. But now we need the x-intercepts so we can find and graph 2 other points. So what we'll do to find the x-intercepts, let's make a little note here. We're going to set the original equation equal to 0 and solve it. And we've done this a lot in chapters 1 and in chapters 2. So our original equation here was y equals 2x squared plus 8x plus 7. Okay, so we're going to take 2x squared plus 8x plus 7 and set it equal to 0 and solve. We have different methods for this. The 2 primary methods I would recommend using are see if you can factor. If you can't factor, try the quadratic formula. Those are basically my 2 go-tos. So if I look at this and see if I can factor it, I would need 2x and x. I would need both signs to be positive. Multiply to 7, add to 8. If I did 7 times 1, this would be 7 and 2, but that's 9. If I did 1 and then 7, This would be 1 and 14. So this one does not factor. So if you can't factor it, which can happen, use the quadratic formula. So let's go ahead and do that and see what we get. So I'm going to erase this part. And let's use our quadratic formula. So we'll have an a, b, and c value. We have a, b, and c. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a and c all over 2 times a. So if we substitute in there, we would get x equals negative 8 plus or minus the square root. I like to go ahead and do b squared right away. So 8 squared would be 64. Minus 4 times 2 for A, 7 for C, all over 2 times A would be 4. And then from here, I would go one step further with my simplifying, and then I'd get my calculator out. So for simplifying here, I'd say x equals negative 8 plus or minus the square root. And then if you just type in 64 minus 4 times 2 times 7 on your calculator, that is 8 all over 4. And then at this point, 8's not a perfect square. And when we graph, it's easiest to graph if we have some decimals instead of square roots. So at this point, we're going to type this in our calculator. We're going to type in negative 8 plus the square root of 8 divided by 4. And we're going to type in negative 8 minus the square root of 8 divided by 4 and get two decimal values. So if you do the first, your decimal value would be negative 1.29. And since this is a 0, we want to write that as an ordered pair. So that's our x value. Our y value is 0. And if you do negative 8 minus root 8 and divide it by 4, you get negative 2.71 and 0 for the y value. So those are the two values we'll put on our graph. These are our two x-intercepts. So if we finish graphing about negative 1.3 and negative 2.7, so about negative 1.3, negative 2.7, and it should be symmetric across your axis of symmetry there. And then we can connect our dots and get our parabola. So there's a sketch using the vertex, the axis of symmetry, and the x-intercepts. So we're going to do one more like this to practice. So again, this would be a good place for you to pause the video, try it on your own, and check your answer. So same exact directions here. Here's our equation this time. So we have y equals negative x squared plus 6x minus 8. So getting this into standard form, I'm going to add the constant over. Do y plus 8, leave a spot to complete the square because I'll know I'll need to do that. And then I have a negative 1 in front of my x squared. So I'm going to divide out a negative 1. So negative 1 divided by negative 1 is just x squared. 6 divided by negative 1 is negative 6x. And then I'm going to put a blank to complete the square. The 8 moved to the other side. Okay, so we have y plus 8 plus something equals negative 1. And then we can complete our square here. So this would be x. Half of negative 6 is negative 3 squared. Negative 3 squared is 9, and then 9 times the negative 1 that we factored out is a negative 9. So we're adding negative 9 to both sides. And then to finish up, we can move the 8 by subtracting it, move the 9 by adding it. That gives us y equals negative 1 times x minus 3 squared, and then negative 8 plus 9 is a positive 1. So for our vertex then, vertex comes directly from this standard form. Here's our h value, here's our k value. So the h value would be a positive 3, the k value would be that positive 1. And then remember, the axis of symmetry comes from that x value. So your axis of symmetry is x equals 3. So we can get our vertex and our axis from the same equation, the same piece of information. So if we put that on our graph, we got 3, 1 for our vertex over 3 up 1. And we have x equals 3 running straight through that point for the axis of symmetry. And then for this one, we have a negative leading coefficient, so it should open down, something like that, but we can figure out our x-intercepts to get a more exact version there. So this one, I've got negative. So if I find my x-intercepts, remember, we're going to take our original equation and we're going to set it equal to 0. So this is to find the x-intercepts. So we'll do negative, and because this is a negative, I'm going to go ahead and factor that out right away. So -1 and then x squared minus 6x plus 8 equals 0. So in terms of finding zeros, I'm only focused on the x values. So if I factor my x values here, I have an x and x. If I want positive 8, I would need two negatives, -4, -2. So in this case, this one does factor. And because I'm only focused on the x values, these are the only two pieces I need to set equal to 0. So that would give me x equals 4 and x equals 2. So our x-intercepts would be 4, 0, and 2, 0. If we put that on our graph, here's 4, 0, here's 2, 0. Those are symmetric. There's a sketch. And again, you can type those equations into Desmos and double check your answers and see that it matches up exactly the same.